Good morning, everyone. My name is Leilei Duan. I'm a teaching postdoc at University of Southern California Spatial Sciences Institute. My co-author, David Wasserman, who cannot be here today, he is a transportation planner and data scientist from Fernand Pierre's San Jose office. Today, we're going to present a generalizable procedural rules for TOD and urban allocation. And a quote inspired from a very interesting and inspirational conversation I had with Joe Minicozy yesterday, and I'm quoting him right here. Sprawl was firstly mentioned in the 1950s, but yet it still keeps happening. So what's wrong? We need to focus on the solutions rather than just emphasizing more on the problems itself. So to reach a possible solution to sprawl or any kinds of other issues, open conversations and communications are the key. So we need to utilize the technologies to build tools and platforms for these conversations to take place. To us, the power of 3D visualizations in the context of urban planning is to empower public and to stimulate these conversations. So when David and I got inspired by this topic, we first looked at the Casa Compact report. So Casa Compact report was created by the Association of Bay Area Governments and MTC, which stands for Metropolitan Transportation Commission. And in the most recent Casa Compact report, which was just published in this January, there were a number of issues being addressed, and one of which is a housing in proximate to transit. And furthermore, in the detailed proposal, it specifically mentioned the minimum zoning near transit portion, emphasizing on the high-quality bus services and major transit stops. And these two maps are also pulled from the Casa report. And based on the map, you can see in the Bay Area, we're facing a real issue on renting problems. So from 2011 till 2016, there are a large number of the area in the Bay Area that has experience with rent increase. And that just put a large group of people at a high risk of being displaced. And based on our statistics, there are at least 38% of the households are cost burdened by housing costs, which means that they pay more than 30% of their income to housing. There are a number of existing research are looking at TOD already. David and I are not the first ones, and we're definitely not going to be the last ones. So most of the approaches so far, they're looking at the issue from two-dimensional. I'm not only talking about they're creating 2D maps. I'm talking about they're approaching this problem by looking at the zoning and also the distance that you are from the service stops. So David and I thought we could take it to a different level. So our goals for this research is that we are going to consider TOD urban forms, including transit frequencies. That's how we add the third dimension into it. And also we are going to actually create a 3D models, that's actual 3D dimension, to represent the TOD development in the San Francisco area. The data we used is quite simple because we're trying to test whether anybody can use this kind of approach. So the data set we used is the San Francisco parcel data set and also the GTFS data set. If you're not familiar with GTFS, it is a standard format that documents the transit services locations and times. So we imported the GTFS data set into the Esri BBB toolbox. That is the Better Bus Buffers toolbox. And then we grab the distance and frequency of the most frequent rail and bus stops information and attach those information to the parcel data. And then we brought this logic into CityEngine and trying to build a model to visualize what we're talking about. So there are four very important variables here, which is decay increment, decay rate, and proximity, which is the distance between your parcel to the nearest service stops, and also initial FAR. So the idea is that initial FAR comes from the frequency of transit. As you move further away from the transit, your FAR bonus will decrease 1 unit of decay rate at every decay increment. And we're implementing TOD overlay zoning at scale using the procedural rules. And the same is calculated with the rail services. So our total bonus TOD FAR is a sum of the bonus FAR from bus services and also the rail services. To extrude the model, we're taking the bottom-up approach, which means that we extrude the building one story at a time to make sure that we reach the target gross floor area. And this GIF shows you how the model actually works in CityEngine. So you can see that our model reacts to the changes to the frequency and proximity to transit. Also, the FAR we're allocating on the right side is the building total FAR that equals to the base FAR that coming from the zoning code plus the TOD bonus FAR, which is separated by bus and rail services. All right, so these are some of the screenshots from the final models. So this one shows a coastal communities in San Francisco, and the color represents FAR contribution from the transit services area. Because like we mentioned, 3D representations are about how to better communicate with public. So we try a different visualization approach here in different styles. And a big shout out to Rakula Nicola, who is a product engineer here at Esri. Thanks to her code online on GitHub, we were able to create this web scene. This, of course, is just a screenshot of the web scene that we created in a sketch style. So up until this point, you may wonder, why do we even sitting here listening to me talking about this? Why do we even care about 3D modeling in TOD? Well, today, there are multiple conversations across multiple states' legislators, including California, asking how do we house the next generation? We are trying to facilitate informed conversations that can use these procedural rules to test and communicate different scenarios. So this is an ongoing project. This is not finished. So what's our next step? Next step, we are actually going to allocate number of residents and number of employees into the different design scenarios. And also, even though that we touch base on what kind of TOD rules should we include in the TOD procedural rules that we created, there are other aspects of TOD that we have not touched. And also, there are other common issues that TOD might bring that we have not touched either. For example, what about gentrification? That's where we actually are asking for your input. So this project is not a funded project. David and I are school friends. We just started this project because we share the same interest and we want to contribute to this area. So this is a joint GitHub project. If any of you are interested, please come to talk to me or David. And you can download our rule from this GitHub link. Please play it as hard as you can, trying to break it as hard as you can. If you can, let us know, we will fix it. So let us know if you have any feedbacks, criticisms, or questions. Thank you very much.